Next we have the preparation methods of amines, and first we will study the first two preparation methods of amines. The first preparation method is by the reduction of nitro group. We know that nitro group, what is the general formula of nitro group? Nitro group is NO2 group. It is NO2. So, how we can convert NO2 group into NH2 group? It is by replacing oxygen atoms by hydrogen atoms. So, we can call it as by reduction. So, NO2 group can be converted to NH2 group by reduction method. Now, what are the reagents used for this reduction? NO2 group can be reduced to primary amines or NH2 by catalytic reduction. We know that what are the reagents that we use for catalytic reduction? Yes, it is hydrogen on or hydrogen gas on palladium or platinum or nickel. So, either we can convert NO2 or we can reduce NO2 group to NH2 by using catalytic reduction, or here we cannot use lithium aluminum hydride and sodium borohydride. The next reagents that we can use here is metals in presence of mineral acids, and the two main metals that we use here is, for example, tin and HCl, or we can use scrap iron and HCl, hydrochloric acid. So, these are the reagents that we can use for the reduction of nitro group to NH2 group. For example, aniline or benzene ring containing, benzene ring containing NH2 on reaction with scrap iron and HCl. We know that how to identify the reaction in organic chemistry. See the reagent written above the arrow. So, iron and scrap iron and HCl written above the arrow means here the reaction taking place is reduction. And we know that NO2 on reduction we are getting NH2. So, how to write the product is replace NO2 by NH2. That means nitro group, how we can convert into aniline? By reduction. This is a very important question, a usual conversion we are doing everywhere. This is nitrobenzene. We can convert into aniline or aminobenzene or benzenamine by reduction. One more example, CH3NO2, above the arrow it is given as hydrogen gas on nickel. So, from the reagent itself we can identify that here the reaction taking place is reduction. So, NO2 group on reduction, what happens? It will become NH2. The remaining part you can copy from the question. So, CH3NH2 we will be getting. So, NO2 group can be converted to NH2 group, or we can prepare amines from nitro compounds by reduction. And these are the reagents that we use for the reduction of NO2 group to NH2. Among these reagents, scrap iron and HCl is the most preferred reagent for the reduction of nitro group. Very important question, note down, the most preferred reagent for the reduction of nitro group is scrap iron and HCl. The reason is, if we want to use scrap iron and HCl as the reagent for the reduction of nitro group, we need to take only small amount of hydrochloric acid along with scrap iron. Because the reason is, when scrap iron reacts with hydrochloric acid, first it forms ferrous chloride, that is FeCl2, which is readily hydrolyzed, which will be readily hydrolyzed to produce hydrochloric acid. So, when we use scrap iron and HCl, we need to use only small amount of hydrochloric acid. The reason is, when scrap iron and hydrochloric acid reacts, first they form ferrous chloride, which on hydrolysis gives hydrochloric acid. So, only to initiate the reaction, we need to take hydrochloric acid, and as the reaction proceeds, what happens, more and more hydrochloric acid will be produced in the medium that can be utilized for further reaction. So, this is the advantage, or this is the reason why scrap iron is used as the best reagent or the most preferred reagent for the conversion of nitro group to NH2 group. That is a very important board question. Now, the second method of preparation of amine, it is from alkyl halides by ammonolysis. We can consider it as a named reaction. We know how to study the named reactions, study the explanation along with equations. Now, how we can prepare amines from alkyl halides? We know alkyl halides general representation is Rx. By ammonolysis, what is meant by ammonolysis? We know about, or we have heard about, electrolysis. Electrolysis means, lysis means splitting, electrolysis means splitting using electricity. And we have studied about hydrolysis. Hydrolysis means splitting using water. So, similarly, here what we can say, ammonolysis means it is splitting using ammonia. And what we are splitting here using ammonia, that is alkyl halides. So, in ammonolysis, we are splitting alkyl halides using ammonia. So, the reagent that we use, first we need to study the reagent for each and every reaction. So, the reagent that we use for ammonolysis is ethanolic ammonia. The reagent that we use for ammonolysis is ethanolic or alcoholic ammonia. Now, the reaction we can understand from the equation. We know that as alkyl halides, we are going to treat with ammonia or ethanolic ammonia plus ammonia. It is understood that it is alcoholic or ethanolic. We know that nitrogen in ammonia, it has two lone pair of electrons. So, it can act as a nucleophile because it is highly electron rich. When alkyl halides react with this ethanolic ammonia, from this what will be eliminated? It is very clear, HX will be eliminated from this, and we will be getting it as, from Rx, X is removed, from NH3 hydrogen is removed. So, here balance NH2 and we are getting it as RNH2 plus HX. So, what we got now here is, we got a primary amine. Now, how we got primary amine from this? From this equation, the reaction is clear. Alkyl halides on reaction with ethanolic ammonia, what is happening? See the reactant and the product. Rx became RNH2. That means in alkyl halide, the halogen atom or the X is substituted by a nucleophile, that is NH2. So, this is a nucleophilic substitution reaction. Once again, when alkyl halides are treated with ethanolic ammonia, undergoes nucleophilic substitution reaction. Why it is called as nucleophilic substitution? Because X is replaced by a nucleophile, that is NH2, in which the halogen atom is replaced by NH2 group. Now, why it is known as ammonolysis? Because here there is splitting of carbon halogen bond. Here the RX bond is breaking. By breaking RX bond only, we are substituting halogen by NH2 group. So there is splitting of carbon halogen bond by using ammonia. So ammonolysis, very simply how we can define it. This is splitting of CX bond using ammonia is called as ammonolysis. Now what is the reaction happening here? When alkyl halides react with ethanolic ammonia, undergoes nucleophilic substitution reactions, in which the halogen atom of alkyl halide will be replaced by the nucleophile, that is NH2 group. So this is about the reaction happening during ammonolysis. So alkyl halides are converted to primary amines. Now the exact reaction happening during the reaction is when alkyl halides are treated with ethanolic ammonia. First they form an addition product, means before they eliminate HX, these two reactants will be added together to form RNH3 plus and X minus. It is an addition product called as substituted ammonium halide. So if we use RCl here, we will be getting here substituted ammonium chloride. From this only they will be eliminating HX. So minus HX, we get what R, NH3 will become NH2, then HX will be eliminated and we are getting primary amine. So this is the actual reaction happening during the reaction. So first we are getting a substituted ammonium halide, which on elimination of HX we are getting primary amine. Now why this addition product is known as substituted ammonium halide? Just compare the formulas. We know that ammonia formula is NH3. When we add one more H plus to this NH3, it will become NH4 plus. And we know that NH4 plus is known as ammonium. Now compare the structure of this ammonium with this product. So here from ammonium, one hydrogen is replaced by one alkyl group. So NH4 plus became RNH3 plus. So substituted product of ammonium. From ammonium, one hydrogen is substituted by an alkyl group. And such compounds or addition products are known as substituted ammonium products. And here it is a halide atom or halide ion. So we can call it as substituted ammonium halide. Okay, so we can compare with this structure. Now, don't think that when alkyl halides react with ammonia, we get only primary amines and the reaction is over. No. When this primary, now we know that when alkyl halides, when they react with ethanolic ammonia, what happens here is, we know that from this HX will be eliminated and we are getting the product as RNH2. Now look at this structure of ammonia here. Ammonia formula is NH3. So what is happening to ammonia during this reaction? Ammonia formula is NH3. When it reacts with RX, what happens here is ammonia, one hydrogen is replaced by one alkyl group, isn't it? Ammonia, one hydrogen is replaced, so it became NH2 replaced by an alkyl group, so it became RNH2. Now there is 2 more hydrogen to replace on nitrogen, isn't it? So this primary amine, again it will be reacting with what? It will be reacting with alkyl halides. Don't think that it will be reacting with ammonia again. We have only one ammonia. Now what we are doing is we are replacing one hydrogen atom of ammonia by alkyl group. So if we want to replace by an alkyl group, we have to treat with more and more RX. So first ammonia treated with RX, ammonolysis happened and we got a primary amine. Now again this primary amine will be reacting with one more molecule of RX. From here also one more HX will be eliminated because there is 2 more hydrogen to replace on nitrogen. And what we will be getting, already we have now NH2 will become NH. Already we have one nitrogen, then one more already we have one alkyl group here, one more alkyl group is coming, so it will become R2NH. So we are getting a secondary amine. Now look at the structure of secondary amine. Now again on secondary amine, again on nitrogen atom we have one more hydrogen to replace. That means one more hydrogen that we can replace by an alkyl group, isn't it? So this secondary amine again will be reacting with what? Not with ammonia. If we want to replace hydrogen by alkyl group, we have to take again another one more molecule of alkyl halide. Again it will be eliminating one more HX. And what we will get here is, already we have 2 alkyl group, one more is coming, so it will become R3. Then NH will become N, so we will be getting a tertiary amine. Now don't think that the reaction is over. In tertiary amine there is no more hydrogen to replace by an alkyl group. So what happens here is, if we are adding one more alkyl halide here, there is nothing to eliminate. There is no hydrogen to eliminate HX. If there is no chance for elimination, what will happen here is there will be addition. So this Rx will be added to this R3N. So we will be getting, as already 3 alkyl groups are there, one more R is coming, so R4. N, when nitrogen gets surrounded by more than 3 groups, when nitrogen gets surrounded by 4 groups, because nitrogen normal valency is 3. When this normal valency exceeds, it will be getting plus sign. Then what is remaining there? X minus. And this is the last product, and the last product is an addition product called as quaternary ammonium halide. Very important term. It is a quaternary ammonium salt. Why it is known as quaternary? If it is NH2, it will be a primary. If it is NH, it will be secondary. If it is N, it will be tertiary. Now after tertiary, one more addition has taken place here. So nitrogen is surrounded by 4 alkyl groups. So it is not tertiary, it is quaternary salt. So the name is quaternary ammonium halide. So this is the last product of addition of Rx to ammonia. And the first step is actually known as what? Ammonolysis. It is splitting of CX bond using ammonia or ethanolic ammonia. Now there is one disadvantage for this ammonolysis. What is the disadvantage of ammonolysis? It is clear from this equation. If we want to prepare only primary amine, it is very difficult to get primary amine only from this reaction, because we will be getting a mixture of primary, secondary, tertiary and quaternary salt. So the main disadvantage of this method is we get a mixture of primary, secondary, tertiary and quaternary salt. And sometimes it is possible to regenerate the primary amine from the substituted ammonium salt. So how we can regenerate the primary amine from the substituted ammonium salt? What is substituted ammonium salt formula? Ammonium formula is NH4 plus. From ammonium, one hydrogen is replaced. So NH4 will become NH3 by an alkyl group. So R NH3 plus X minus. Don't try to by heart. Understand the formula and study. Okay. To this, from this we can regenerate the first primary amine or the original primary amine by treating with a strong base like NaOH. From this, it will be eliminating NaX and one water molecule, one hydrogen from here, one OH from here. So, one NaX will go, one water will go. Now remaining what we have are NH3 will become NH2. And we will be getting the primary amines back. So how we can regenerate primary amine from the substituted ammonium salt? By treating with a strong base like NaOH. So this is about the first two preparation methods of amines by the reduction of nitro group and by ammonolysis. Now in the in-text solved question, that is 13.1, there is a question to write the equations of the reaction of C2H5Cl with ethanolic ammonia. So how we can write the reactions or equations of the reaction between C2H5Cl and ethanolic ammonia. So C2H5Cl plus ethanolic ammonia. First, from this it will be eliminating HX minus HCl. Here X is Cl. So HCl will be eliminated and we get C2H5 balance here in H2. So we got a primary amine, and this primary amine again will be reacting with RX. So which is the RX here? C2H5Cl. So again with C2H5Cl, again it will be eliminating one HCl minus HCl, and we get already one C2H5 is there. From NH2 one hydrogen is removed to eliminate HCl, so it will become NH. One more C2H5 is coming, so it will become C2H5 twice NH. Now it has one more hydrogen to replace, so it will be reacting with one more molecule of C2H5Cl, and from this again one more HCl will be eliminating, and we will be getting it as C2H5 twice will become C2H5 thrice, because one more C2H5 is coming from here, and NH will become N. And if we want, we can write the reaction till the addition product, that is a quaternary ammonium salt, or we can stop till tertiary amine. So this is about the reaction between C2H5Cl and ammonia. Now the second question in this exercise, it is ammonolysis of benzyl chloride. Benzyl chloride with 2 moles of C2H5Cl. Ammonolysis of benzyl chloride with ethanolic ammonia, and the amine formed is reacting with 2 moles of CH3Cl. So how we can write the equation as? We know benzyl chloride formula is benzene ring CH2Cl, because we know that benzyl group is C6H5CH2. So it is reacting with ethanolic ammonia, and we know that from this HCl will be eliminated, so minus HCl, and we are getting it as benzene ring, no change, CH2, no change. Instead of Cl, what will be coming here? NH3 will become NH2. Now the question is, benzyl chloride reacts with ethanolic ammonia, gives a primary amine, and it is reacting with 2 moles of CH3Cl. So now it has to react with 2 moles of CH3Cl. So reacting with first molecule of CH3Cl, and there is elimination of 1 more HCl from here, and we get benzene ring, CH2, NH2 will become NH, CH3. Now it has to react with 1 more molecule of CH3Cl. So 1 more HCl will be eliminating. So take always hydrogen from nitrogen only. So minus HCl. The final product is benzene ring, CH2. Now we have only 1 nitrogen there, surrounded by 2 methyl group, which is a tertiary amine. And this is a secondary amine. And this is a primary amine. So these are the examples of ammonolysis reaction taking place in alkyl halides. So we can prepare amines from alkyl halides by ammonolysis. And remember, for ammonolysis we can use alkyl and benzyl halides. Okay, we cannot use aryl halides for ammonolysis, but we can use alkyl halides, that is RX, and benzylic halides. Benzylic halides means benzene ring containing CH2X, because if this X is directly attached to benzene ring, we know that there will be resonance, there will be double bond character, difficult to replace. So aryl halides cannot undergo ammonolysis. Only benzylic halides and alkyl halides can undergo ammonolysis. Thank you.